All right, it's going to be part two of the state machines and talking about the toll booth. And we're going to actually talk about how to build the state transition table. So last video we went over the state graph, and one thing I want to just a little reminder about is the um, two parts to a state. Remember, we have part one where it's in, I'll call the idle state, where it stays in the state, there's no change. Then something on the input changes and we have this transition arc and we go to the next stage. So that's part two of that. So in keeping that theme, what I'd like to do is go over here to our state transition table. The state transition table looks just like our regular truth table. We have inputs on the left. Right here are inputs. And on the right hand side we have our outputs. Now they are subdivided a little bit. We've got next state, outputs, present state, inputs. So we'll talk about that as we build this. If you notice, we've got the little letters up here. Here's our two flip-flops, QA and QB. Here's our open switch, our closed switch, our open limit switch that tells the gate's all the way open, and our closed limit switch, the switch that says the gate is closed. So let's take a look at these first two columns right here. Let's talk about those. And remember over here, part one and part two of a state. So if we start building this thing, as you notice, the states go down here, and there's two state zeros, two state ones, two state twos, and two state threes. And once again, they refer to, for example, this is that section right there, part one of that. And then this is the second part of state zero. And each of the states going around 1, 2, and 3 had the same situation. So now if we look at QA and QB, it's just 0, 0, 0, 0. We drop down here to state 1, well, that's 0, 1. Follows the state numbering, or you can actually look over here. Here's all these, the QA and the QBs from each one of these. So we fill in, now we're state 2, we fill that in, 2 lines for that, 2 lines for state 3, and that finishes our rows for our input. Now we're going to look inside this area right here. Inside this area right here is our inputs for the first row. So if we take a look, the open switch has not been pushed, so it's a 0. So if we follow that all the way over here, there's its value right there. Then the closed switches don't care, the open limit switches don't care, and the closed limit switches don't care. So we fill in X's there for don't care. All right, next we go to part 2 of state 0. That's this transition here. Now, this is the little signal, the open switch push button that the operator pushed to open the gate. It causes our transition. And so this is our part 2 of state 0. So that signal is right there. We look at the other inputs, they're all don't cares, so we fill in don't cares there. All right, next we're going to go down, we're going to fill in this section right here. And if we look at our idle state, that's the first row of state 1. Right here, our open limit switch is equal to 0. So if we come across here, open limits equal to 0. Our other input states are don't care, so we fill them in with X's. And then we look at our transition, part 2 of state 1. The key to that is the open limit switch has been hit. That means the gate went all the way up, hit the open limit switch. All right, so right here we set that to a 1. The other switch inputs, push buttons, and limit switches are don't cares. All right, now we're down here in state 2. We look at the idle state because that's the first row in state 2. And the one we care about is the closed switch. So nobody is pushing the closed switch, so the closed switch equals 0. And our other inputs are don't cares. Now we look at this transition right here, part 2, or row 2 of state 2. and we see the close switch. Somebody pushes the close switch. So we have close switch equal to 1. We have don't care and don't care. Are you going to get that? Excuse me here. I had a little text message coming in. Anyway, if we take a look, now we're down to state 3. If we look at the idle section of it, the close limit switch equals 0. Close limit switch equals 0 over here. We fill in the don't cares. And now we look at part 2 of state 3, that transition arc. And this is what we care about, the closed limit switch equal to 1. Closed limit switch equals 1, and our other 3 inputs are 0. All right, now we've just completed our input side of the transition table. And now this is what makes the state machine work. If we go to our output side, we have this 2 columns here labeled next state. And little stars here mean next state of the flip-flops. So the first row here is basically the outputs of state 0 right here in the idle mode. So we can copy these right here, this information. We copy that, and we're just going to put it over here in our 4 outputs. So motor open equals 0, motor closed equals 0, gate open equals 0, and gate closed equals 1. So we fill, there's gate closed equal 1. These we fill in as zeros. And we're staying in state 0. So we go from state 0 to the next state. Well, it's state 0. That's that idle state. Remember? We're sitting in this idle state right here going around. So I'm in state 0. I stay in state 0. So now here's what makes this state table, putting it together, work, makes the state machine works. This is our transition arc right here. That's where we transition to the next state, state 1. So over here, what is the next state on that transition arc? Well, it's state 1. So we fill in these two. Remember, QA and QB goes from 0, 0 right here to 0, 1. So we fill that in. And then we look, our outputs will stay the same because nothing has happened to our outputs. You notice there's no, on this transition arc, nothing changes on our outputs until we hit state 1. So we just copy this portion of the row right down to here. So we're on that transition arc. Outputs haven't changed. All right. And we're heading to be in state 1. So as soon as we get into state 1 right here, that's this row. So that's right here. All right. And when we're in state 1, what are our outputs? Well, motor open equals a 1. And here are our other outputs. So now we got to change our outputs. So we go over here, we look at our outputs. The state is state 1, so this is a 0, 1. And we change our output. The motor goes on, so we change motor open to a 1. The other thing we change is gate closed. That LED no longer says the gate's closed because the motor's turned on and now the gate's opening. So that goes to a 0, and we fill these two in 0. Remember, this comes from right here, these outputs. So that's how the table gets filled in. All right, next. We're in state 1, and now we're going to transition to state 2. So that's this line right here. So this arc transition is right here. We go to state 2. Remember, this is what makes this table work, is this next state here. We fill it. So we put a 1, 0 in there. And remember, our outputs aren't going to change because we're on this transition arc. The outputs don't change. So they stay the same as the previous row, so we just leave those the same. And then all of a sudden, boom, we're in state 2. That's right here. We're in the full-fledged state 2 right there now. And state 2's outputs, we take a look at them right here. And gate open equals a 1. So we come over here under gate open, it equals a 1. Our other outputs, motor open's turned off, motor close was off, and gate close was off, so they stay off. So now we've just landed in state 2. Oh, also we have the state, it stays the same in state 2. Next we want to go to the transition state. We want to go, this is the idle state right here, this line. Now what happens is somebody hits the close switch to close the gate, and that means we're going to go down here. We're going to go from state 2 to state 3. Here's state 3. We put state 3 in here. These outputs all stay the same because we're on this transition arc. The outputs don't change. They stay the same until we get down to the idle state of state 3. We get in the idle state, boom, there's our outputs. Motor closing is turned on. Whoops, got to turn our, put our state 3, there already are state 3, state 3. Here, gate open now, it's going to be not gate open anymore, so we change its status. This stays the same, and this one stays the same as the previous. And now finally, we're in state 3. That's what this line's about right here. This whole line is state 3. And now we go transition back to state 0. Right here, that's the close limit switch caused it. And so we're on this transition, and we're going. We change our state here to 0, 0, because that's where we're going to. So it's the next state. The outputs stay the same because outputs haven't changed yet until we get ourselves back up here to state 0. Once we get back up to state 0, we land in state 0. Our outputs are this. We shut the motor off. The motor closed, turns off, as you notice, changed from there to there. And gate closed goes to a 1. So now we're ready to go fire the state machine off and start again at state 0. All right, now here's what I'm going to do. I want to erase these. I'm going to erase all my lines here. But that's how we build this table. It's pretty straightforward. You got to remember, actually, I took a course in college. It was called Finite State Machines and Automata Theory. That was a whole semester course. And here we're going to jam this into a couple weeks with our students and the topic here. So, I mean, they're getting a lot of information here, but they do give you a lot of information. But trying to understand how to build it and everything probably is the roughest thing here. All right, so I want to erase all my yellow lines. And actually, I think what I'm going to do is I'm just going to go to the next page on the PowerPoint. Yeah, I'm going to go to this page. It's kind of clear. Now, we've got our transition table all filled out, just like we got a regular truth table filled out. What we need to do is we need to go over here to our outputs. We have 1, 2, 3, 4, 5, 6 outputs that we got to do things for. Now remember, QA, we're going to really find out that this column is the DA, the input D on the QA flip-flop. That's what this column is going to be. This column is going to be the D input. It's going to be the combinational logic goes into the D input on the B, QB flip-flop. If you notice down here, they've equated DA and QA bar, DB and QB bar. So this will be the equation that goes in front of that flip-flop, those two flip-flops in the center of our machine. So let's figure out how to factor this right here. So I'm going to go to this column right here, and I start at the top. Remember, we're going to write our standard sum of products. In sum of products, we write the equation for all the ones. So here's my first 1 right there. If I go over here, I don't do anything with the x's. We forget about the x's. But right here, I see a 0, so that's going to be QA bar. So if we take a look at it, QA bar, it's right there. Next one is QB. So we write that right there. And then the next one is going to be OL. Because it's a 1, it's an OL, not an OL bar. So we write that right down there. So that's the min term. This is the min term for that 1 right there. Now we come down to our next 1. And we write that min term. And what's it got to be? It's got to be QA, QB bar. So if I go down here, here's QA, QB bar. If we follow it over here, it's the closed switch bar, closed switch bar, which they got right there. So they write that one. So that's my second minterm. Now I come down here, here's my next one. So I'm going to write its minterm. So it's QA, QB bar, and CS. So QA, QB bar, CS. So that's that one. It's midterm. And then our last midterm is right here. If I come over, it's QA, QB, and we come all the way over here to the closed limit switch bar. So QA, QB, closed limit switch bar. So now there's our expression that's going to go in front of the D input of the QA flip-flop. That's going to be the combinational logic in front of it. Actually, the students can simplify this. I can see a simplification right here. I could take QA and QB bar out, and I'll be left with CS bar ORed with CS. But I'm not going to go into the simplifications of that. All right, we do the same thing here. We're going to write 4 minterms for these ones right there, and we're going to come up with this equation. Then motor open. This is going to be the signal that goes to the actual motor open pin on the H bridge that we're using. And if we take a look, I got two minterms here. First one's going to be QA bar, QB, and then OL bar. Second one's going to be QA bar, QB, and then it's going to be OL bar. I'm sorry, OL. So if you take a look, what they did for this already is they wrote the equation down here and they simplified it for you already. And follow here, we do this for the motor closed. This goes to the H bridge closed pin. This is gate open, and then this is gate closed. There's the 2 terms for those LEDs. And then we got these terms right here for the gate closed LED. Maybe I said that about this one, but gate closed LED. So here's our 4 output combinational logic. That's on the output side. And our input combinational logic are these 2 equations. And what I'm going to do is I'm going to go over this a little bit later. I think what I'm going to do is I'm going to stop here. What I've gone through is this is part 2 of the PowerPoint, and it kind of shows you how to build the whole transition state table and everything. I think the third part of the PowerPoint is I'm going to talk a little bit about the phone number project, and that's what's next in the PowerPoint. So this is where I'm going to stop at this point.